Welcome to day one of the summer math operations course. So this class goes very slow and it begins by reviewing all of the basics, and we gradually introduce the things that you need to know by the start of ninth grade. So our agenda for today, we're going to learn place values, exponents, power of 10, and scientific notation and comparing and ordering. And then we have some classwork and homework practice problems, which are all part of the notes, so we're going to do them all together. So first we have place values, which another name for it is expanded notation. And in expanded notation, each place is 10 times the value of its place to the right. So if we look at this chart, we have the ones place, then the tens place, 100s, 1,000, 10,000, 100,000, 1,000,000. So all of these on the left side here are whole numbers. And then all of them on the right side, we have 1/10th, 100th, 1,000th, 1/10,000th, 100,000th, and 1,000,000th. All of these on the right side are decimals, which they all end with that TH. So all of them, all the decimals end with the TH when we read it out loud. When reading whole numbers, we read as if we are reading each place value. The places are grouped into sets of 3 separated by commas as shown below, and each group is called a period. So here, this group is a period, and we have the ones, which is where we start. Then as we get into our higher numbers, we have the thousands, millions, billions, and trillions. So looking at our example here, we have 64, 206, 011. So when reading this number out loud, we start with our largest period, which is farthest to the left, and we read the number in this period followed by the word million, since it's in our millions place. So we would read it as 64 million. Next, we would read the number in the thousands place, followed by the word thousand, and that is 206,000. And then we would read the number in the ones period without the period name, so it would just be 11. So altogether, we would read 64,206,011. So looking at example 1, we have 2,342, and it's read as 2,342. And if we were to write it in expanded notation, we write each place value times the number. So since 2 is in the 1,000 place value, the thousands, it's read as 2 times 1,000, and then we just add each together. So then we have the 3 that's in the hundreds place, so plus 3 times 100. We have the 4 in the tens place, so plus 4 times 10, and then the 2 in the ones place, so plus 2 times 1. Right, next for number 2, we have 4,236,764.325. So we would read this as 4,236,764 and 325 thousandths. So the only time that we use this word and is when we have a decimal. So here we would write this in expanded notation. We start with our largest number, which is 4, and it's in the millionths place. So we would have 4 times 1,000,000 plus 2 times 100,000 plus 3 times 10,000 plus 6 times 1,000 plus 7 times 100 plus 6 times 10 plus 1 times 4. Now we get to our decimals, which those we have 3 times. Since it's the 10th place, we would have 3 times 1 over 10. Next, we have our hundredths place, which would be 2 times 1 over 100. And last, we have our thousandths place, which would be 5 times 1 over 1,000. When we write this in scientific notation, each number needs to be represented by its place value. So we have the 4 that's represented, 2, 3, 6, 7. All of our numbers are represented by its place value in expanded notation. So next we have number 3. We have 34.57. We would read this as 34 and, since we have a decimal, 57 hundredths. In expanded notation, we would have 3 times 10 plus 4 times 1 plus 5 times 1/10 plus 7 times 100, 1 over 100. So next for number 4, we have 673.15. We would read this as 673 and 15 hundredths. In expanded notation, we would write this as 6 times 100 plus 7 times 10 plus 3 times 1 plus 1 times 1 over 10 plus 5 times 1 over 100. Okay, and our last one from this section, number 5, we have 6, 4, 5, 0, 001, 000, 002. We would read this as 6,450,000,000,1,000,002. So here we wouldn't need this and, we would just put comma 2. In expanded notation, we would have 6 times 1 trillion, since that 6 is in the trillionths place, plus 4 times 100 billion, plus 5 times 10 billion, plus 1 times 1 million, plus 2 times 1, since that 2 is in the ones place. For A, when we write this in words, this would be 200 9. For B, this would be 3,000 Next we have our hundreds place, so it would be 494. For C, we have 10,006, so we would write this just as 10,000, comma 6. D, we have 305,009, so 300 5,000 comma 9. E, we have 7.62, which would be 7 and 62 hundredths, since our last decimal place is in that hundredths place. So this would be 7 and, to represent the decimal, 62 hundredths. So that was E, and now F. We have 42.6, so we would write this as 42 and 6 tenths, since the 6 is in our tenths decimal place. So 42 and 6 tenths. G, our last number is in, this would be tenths, hundredths, thousandths, so this one would be 10 thousandths. So 1/10 10 thousandths. Remember, we need that TH at the end, which represents that it's a decimal. And then our last one, we have 3.0, which would just be written as 3 and 0 tenths. We could also just write this as 3. So for 16, now we're going to go the other way. So it's going to give us our number written out in words, and we need to write the number down. So for part A, we have 565, so this would be written as 565. For B, we have 3,500, so 3,500. C, 10,004,002. So this would be 10,004,000. So we have 0, 0, 4, and then it ends with 2. So then we have 0, 0, 2. For D, we have 70,901 and 1/10. So we need 70,901 and 1/10. So to write 901 would be 901. And we put our point, 1/10 would just be 1 in the tenths place. E, we have 2 and 99 hundredths, so 2 and 99 hundredths. So as long as our last number is in that hundredths place, we're good. And then for F, we have 4 trillion 90 billion. So 4 trillion 90 billion, we would need 0, 9, 0. And then we just need to fill in all the zeros to make this in the trillions place. So this one would be millions, then we would have thousands, and then we would have our ones. So as long as this is trillions, this is billions, this is millions, this is thousands, and this is our hundredths. Next we have exponents, powers of 10, and scientific notation. So an exponent tells the number of times a base is used as a factor. So here we have 10 to the third power. 10 to the third power would also be read as 10 cubed. If we had 10 to the second power, this would be read as 10 squared. But any higher, we just read it as the number that it is. So if we had 10 to the fourth power, it would just be 10 to the fourth power. An exponent can be written as positive, negative, or 0. A negative exponent can be written as a unit fraction with a positive exponent in the denominator. So if we had 10 to the negative 3, we would bring it to the denominator and make it a positive 3. So it becomes 1 over 10 to the positive 3, which would be like saying 1 over 10 times 10 times 10, which would be 1 over 1,000. Same thing if we had 5 to the negative 2 power. It would be 1 over 5 to the positive 2, which is just 1 over 5 times 5, which is 1 over 25. Any non-zero number raised to the 0 power is equal to 1. So it doesn't matter what our number is, if it's raised to the 0 power, then it's going to be equal to 1. So if we have 10 to the power of 0, it's equal to 1. 5 to the power of 0 is equal to 1. 700 to the power of 0 is equal to 1. Any number raised to the first power equals itself. So 10 to the first power is 10, 5 to the first power, 5, 9,000 to the first power is 9,000. Also, 1 raised to any power is itself. So 1 raised to the 0 power would be 1, 1 raised to the first power is 1. 1 raised to the fourth power would be 1. If we had 1 raised to the 27th power, it would be 1. So exponential equations can be evaluated by performing repeated multiplication. So that would be if we had like 10 to the third power, it would be 10 times 10 times 10. We just repeat the multiplication, or we could use this button in our calculator. So here we have some examples. These examples are done for us. So looking at number 1, the number 7 is to be used as a factor 3 times. So our base is 7. And a factor means that we're multiplying, so it would be 7 times 7 times 7 3 times. We could also write this as 7 cubed. For number 2, we need to write the expression using exponents. So here we have 4 3 times, 3 4 times. So since we have 3 4s, we would write this as 4 to the third power times, since we have 4 3s here, we would write this as 3 to the fourth power. Number 3, we need to find the value of each expression. So for A, this would be 10 times 10 times 10 times 10, which if we multiply it all together, it would just be 10,000. For B, we have 2 to the fifth power, so this would be 2 times 2 times 2 times 2 times 2, 5 times, which would be 32. For C, since we have a negative exponent, 3 to the negative 2, we would change it to become 1 over 3 squared. So we keep the 1 on top the same, and we need to evaluate the 3 squared, which would be like 3 times 3, which would be 1 over 9. For D, we know anything raised to the power of 0 is 1. And for E, 1 raised to any power would just be itself 1. Okay, here we have laws of exponents. We can add, subtract, multiply, and divide exponents according to the following laws. So for addition, like bases with unlike exponents cannot be added unless they are evaluated first. Same thing with subtraction. Like bases with unlike exponents cannot be subtracted unless they are evaluated first. So looking at these examples, we cannot combine these two together unless we evaluate it first. So we would have to find what 2 squared is, which is 4, and then add 2 to the fourth power, which is 16, and then we can combine them. 4 plus 16 is 20. Same thing with the second example, we need to evaluate it first. Same thing with subtraction. We cannot combine these two unless we evaluate it first. So we would need to find 3 to the fifth power, which is 243, and then subtract 3 squared, which is 9. So for addition and subtraction, in order to combine it, we have to evaluate first. For multiplication and division, to multiply powers of like bases, we keep the bases and add the exponents. So in order to do this, we have to have like bases. So here, when we have our bases that are like, so we have 4 squared times 4 to the sixth power, since those 4s are the same, and we're multiplying, we can combine our exponents by adding them together. When dividing like bases, again, our bases need to be like, we keep the base and subtract the exponents. So here we have 7 to the fourth power divided by 7 squared. So this becomes 7 raised to the 4 minus 2. So since we're dividing, we subtract. and 4 minus 2 is 2, so it would be 7 squared. So we can only do this if we have like bases. Okay, so here we have more problems that are done for us. So which of the following is not equal to 3 times 3 times 3 plus 3 times 3? So here we would rewrite this as 3 cubed plus 3 squared, since we have 3 3's here and 2 3's here. And since we're adding them, we cannot combine them. So we know we can write it as this, and we just said since we're adding them, we can't combine it unless we evaluate it first. So it would not be equal to b, because b combines them before evaluating. Number 2, which of the following is not equal to 2 to the 5th power minus 2 to the 4th power? Again, we said we cannot combine them unless we evaluate it first. So the one that combines them before it evaluates would be F. Number 3, here we're multiplying, so we can combine our exponents by adding them. So we have 5, so we're adding them, so 2 plus 3. So 5 raised to the 2 plus 3 becomes 5 to the 5th power, and 5 to the 5th power would be 3,125. And for number 4, since we're dividing, we can combine them by subtracting. So we keep our base the same and we subtract our exponent. So we have 6 minus 2. 6 minus 2 is 4, so this would be 5 to the 4th power, which we would evaluate as 625. Okay, now we're moving on to powers of 10, which is the same thing from before, but now we're multiplying them out. So all of our whole numbers on the left side of the table are represented by positive exponents, and all of our decimals on the right side of the table are represented by negative exponents. This brings us to scientific notation. We use scientific notation when dealing with really big numbers or really small numbers. So looking at our examples, we have a micrometer is a very small unit of length equal to 0.0003937 inch. Express the number in scientific notation. So scientific notation, we move the decimal point to the right, so the first factor is between 1 and 10. So when moving this decimal, we are moving it 1, 2, 3, 4, 5 places. So now we would have 3.937 times 10, and we just said we move this 5 decimal places. If we're moving the number to the right, our exponent would be negative, so we make it -5. One way to remember this is if it's really small, your exponent is going to be negative. If it was a really big number, our exponent is positive. So looking at number 2, we need to count how many times we move our decimal place. So we move it 1, 2, 3, 4, 5, 6. So we would have 2 times 10 raised to the 6th power. Here we have a really big number. We have 2 million. So our exponent on the 10 would be a positive number. Again, we have a big number here, so we know our exponent is going to be positive, but we just need to find out what number that exponent is. So we need to count how many times we move our decimal. So we move it 1, 2, 3. So we have 7.8 times 10 to the 3rd power. And then for number 4, we're moving it to the right. Since we start with a decimal, we know our exponent is going to be negative. So we're going to move it 1, 2 places. So we have 6.5 times 10 to the -2. And again, we're moving it until our number that we start with out front here is in between 1 and 10. So this box tells us here that when we start with a number greater than 1, we're going to have a positive exponent. When we start with a number that is less than 1, so a decimal, would be a negative exponent. Numbers written in scientific notation can be written in decimal notation or standard form by expanding the power of 10 and multiplying. So here we're going the opposite way. So it gives us a number in scientific notation and we need to put it into standard form. So the exponent just tells us how many times we're moving the decimal. Since it's positive, we're going to make this a bigger number, so we move it to the right. So we would move our decimal 3 times. So 1, 2, 3. So this becomes 208, and then we would just need to add a 0, and then we put our comma there. So we have 2080. For number 1 in our examples here, we are going to move our decimal 8 places to the right. So we have 1, 2, 3, 4, 5, 6, 7, 8, and now we can just fill all these in with zeros. So we have 2, 5, 2, and then we have 6 zeros. 1, 2, 3, 4, 5, 6, and we're going to put our comma after every 3 terms. So we have 252 million here. Our next one tells us the distance from Earth to the Sun is 9.3 times 10 to the 7th power miles. So since this is a positive exponent, we move our decimal to the right 7 places. So we have 1, 2, 3, 4, 5, 6, 7, and we fill all those in with zeros. So here we have 6 zeros. So this becomes 9, 3, and then we write all of our zeros. And then after we write our zeros, we're going to write our commas. So we have 93 million miles. Number 3, we have 1 times 10 to the negative 3rd power. So we're going to move this to the left now since our exponent is negative. So our decimal originally is there, and now we move it to the left 3 places. So 1, 2, 3, and now our decimal is right there. And we just fill in our zeros there. So we have 0.001, which would be 1,000th. Again, we have a negative exponent for number 4, so we're going to move this to the left 5 places. So we have 1, 2, 3, 4, 5. Our new decimal place is right there, and we need to fill all of these in with zeros. So we have 4 zeros, so we have 0.000327. And this just says, remember when numbers are between 0 and 1, in scientific notation, the power of 10 is written with a negative exponent. So here we have some short response questions. We need to find the value of z. So we have 3 to the 3rd power plus 4 squared plus 5 to the 1st power. Since all of these have different bases and we're adding them, we can't combine them until we evaluate. So first we need to find what 3 to the 3rd power is. It would be 3 times 3 times 3, which is 27, plus 4 times 4, which is 16, plus 5. 27 plus 16 is 43. 43 plus 5 would be 48. Number 20, a satellite leaves Earth and travels 5.7 times 10 to the 7th power miles. Express the distance in standard form. So since our exponent is 7, we're going to move our decimal 7 places. So we have 1, 2, 3, 4, 5, 6, 7. And we fill all of these in with zeros. So we have 6 zeros here. So we have 5, 7, 1, 2, 3, 4, 5, 6. And then we're going to put our comma after every 3rd number. So we have 57 million. Number 21, to express 185,000 in scientific notation, Joey wrote 18.5 times 10.4. Was Joey's answer correct? Explain. So here we know that Joey's not correct because this number needs to be between 1 and 10, and 18 is more than 10, so that's not right. So we would just have to move our decimal one more place. So when writing this in scientific notation, we count how many times we move our decimal, so it goes from there to 1, 2, 3, 4, 5. So we have 1.85 times 10 to the 5th power. Number 22, what is half of 2 to the 10th power? Express your answer in exponential form and show your work. So half of 2 to the 10th power would be whatever 2 to the 10th power is divided by 2. So 2 to the 10th power divided by 2. Just 2 would be 2 to the 1st power. And now that we are dividing, we can combine these by subtracting our exponents. So this would be written as 2 times 10 minus 1. 10 minus 1 is 9, so this would be 2 to the 9th power. Number 23. To simplify this, again, we are dividing. So that means we subtract our exponent. So we have 7 to the 11th power minus 9. 11 minus 9 is 2, so this would be 7 squared. Next, we have comparing and ordering. When comparing and ordering numbers, we need to think about where the numbers would fall on the number line. So here we have our greater than symbol and our less than symbol. And it always points to the smaller number. So looking at example 1, 4.9 is to the right of 3.5, so 4.9 is greater than 3.5. 0.6 is to the left of 1.3, so 0.6 would be less than 1.3. To compare two or more whole numbers or decimals without using the number line, we can align the places and work from left to right. And we need to find the first place where the numbers differ. So looking at example 1 here, our 7s are the same, our 2s are the same, but here we have 8 is bigger than 10, so we would write this as 7.286 would be greater than 7.259. For number 2, we do the same thing. Our 4s are the same, our 7s are the same, our 3s are the same. Here we could just fill this in with a 0. 0 is less than 8, so 47 3/10 would be less than 47 3/38. In our first problem here, the average speed in miles per hour of 3 cars in a race were 147 35 thousandths, 150 686 thousandths, and 144 317 thousandths. So we can compare these by writing them on top of each other. So we have 147.350, 150.686, and then 144.317. So we start with our first column. All the ones are the same, so we can cancel that out. Next, looking here, it says we need to order it from least to greatest. So we're looking for our smaller number first. So we have 2 that have 4s. And then next, out of these 2, so I'm just going to ignore the middle one for now, we have 4 and 7. 4 and 7. Our 4 is smaller than 7, So 144.317 is going to be our smallest number. So that is less than our next number would now be 147.350, and then our last number would be 150.686. For number 2, we just need to compare the numbers using greater than or less than. These numbers here are written in scientific notation, so what we can do is change it to standard form. So our exponent tells us we're going to move this decimal 4 places to the right. So we have 1, 2, 3, 4. So we're going to have 35 and then 3 zeros. So 35,000. Our next number, we're going to move our decimal 3 places to the right. So we have 1, 2, 3. So here we would have 2 zeros. So 62, 2 zeros. So this would be 6,200. 35,000 is bigger than 6,200, so we would put a greater than sign there. Next, our exponents are the same. In both of these, we have 10 to the 7th power, so we just need to look at our number at the front. So we have 5.3 and 1.15. So 5 and 3/10 would be greater than 1 and 1500. So for C, we could rewrite this again. We're moving our decimal to the left now since our exponents are negative. So we would move this to the left 5 places. So 1, 2, 3, 4, 5. And our new decimal is there. Now we need to fill all of these in with zeros. So we have point, and we have 4 zeros. 1, 2, 3, 4. 46. And then next, we're going to move this 4 decimal places. So 1, 2, 3, 4. So we're going to have 3 zeros here. So 0.1, 2, 3. Now, if we were to line these up on top of each other, we have 0, 0, 0, 4, 6. So the zeros are the same. And next we have a 0 and a 4. 4 is greater than 0. So 0.00046 would be greater than. Next, we have D, which we know that moving this 2 decimal places makes this 735. Moving this 10 decimal places to the left would make this 0.000 with 9 zeros. So obviously 735 is greater than a really small decimal. For number 13, so here we need to determine if it's greater than or less than just by using our number line. So we know that the bigger numbers are to the right and the smaller numbers are to the left. So here we have A and Y. Y is farther to the right, so Y would be greater than. Next we have D and C. D is to the right, so D would be greater than. Then we have N and Y. Y is to the right, so Y would be greater than. Now we have D, N, and C. So D is all the way to the right, so this is going to be the biggest one. Then we have N, which is bigger than C. Next we have C, A, and Y. So we start with C, go to A, and then Y. C is all the way to the left, so this is going to be smallest, so we put a less than, and then A is to the left of Y, so A is going to be less than Y. And then our last example, F, we have Y, D, and A. Y is all the way to the right, so that is going to be our biggest number. So Y is going to be greater than D, and D is going to be greater than A. For 14, we need to put the cities in order of price from greatest to least. So perfect, they're already in line for us, and all of these have a 1 in the ones place, so we don't even need to look at those. Next, we need to look at our tenths place. So we're starting with our greatest one. So 5 would be our highest number in the tenths place. So Los Angeles is going to be our first one. So we can cross this out. Next, we have a 4 in the tenths place for Seattle. So this is going to be our second biggest. Next, we have a 2 and a 2. So then we would need to go to our hundredths place. So in New York, we have 9. In Chicago, we have 1. 9 is greater than 1. So New York would be our third greatest. Chicago would be our fourth greatest. So we can cross these out now. And then here in Miami, we have a 1 and a 1. So we need to go to our hundredths place. So we have a 4 and a 1. 4 is greater than 1. So Miami comes next. And then Boston comes after that. We can cross these out. And then we're just left with our 0 place here. So we can cross those out. 7 is greater than 6. So Denver would be our 7th largest. And Houston would be our smallest. Okay, in 15, we're doing the same. We're ordering now from least to greatest. So we start with our smallest one. So we can rewrite all of these as standard form. So we're going to move it 7 places to the right. So we have 1, 2, 7. So we move it 1, 2, 3, 4, 5, 6, 7. So we're going to have 1, 2, 3, 4, 5 zeros. And then we can put our commas. So after every 3 numbers, we put a comma. Next, we have 5.79 times 10 to the 6. So here we would have 4 zeros. And then we can put our commas. And then our last number here, we have 9.3. So when we would move this, we have 5 zeros. 1, 2, 3, 4, 5. And then we can put our commas. So here we have 12 million, then we have 5 million and 9 million. So 12 is going to be, we're starting with the least. So our smallest one would be 5,790,000. And then we would have 9,300,000. And then our greatest number would be 12,700,000. Okay, we're going to do the same thing for B. So here we have negative exponents, so we're going to move it to the left. So 1, 2, 3, 4. So we're going to have our decimal, then 3 zeros, 3 and 6. Next we have, again we're moving it 4 places. So we have our decimal, 3 zeros, 4, 8. And here we're moving it 5 places. So we're going to have our decimal, then 4 zeros, then 9, 9, 8. So we could line these up and see which ones are smallest, but we know that the more decimal places we have, the smaller the number is. So our smallest one here would be 0.000998. Our next smallest would be 0.003, so we have 3 zeros, so 0.00036, and then our largest number would be 0.00048. Now we move on to our classwork/homework section for day 1. So looking at number 1, we would read this as 1,436 and 6/100ths. So we can cancel out A, cancel out B, and 6/100ths would be C. Next, we can write this in expanded notation. Remember, each number needs to be expressed in our expanded notation. So our 1 is in the thousandths place, so we can cancel out F, and then we're left with G. So we would have 1/1000 plus 4 times 100 plus 3 times 10 plus 6 times 1 plus 6/100ths. So that would be G. Number 3, the expanded notation of 193 and 4/1000ths. So we need this 4/1000ths to be written as a fraction. So we can cancel out C, cancel out B, cancel out A, and we're just left with D, because this is the only one that shows that decimal written as 4 times 1/1000. Next, we have number 4, so 243 and 708 thousandths. So to write this in expanded notation, we would need 2 times 100 plus 4 times 10 plus 3 times 1 plus 7 times 1/10, since that's in our tenths place, plus 8 times 1/1000, since that's in our 1000ths place. And since 0 is in our hundredths place, we don't need to write that. So we don't need to write the zeros when writing expanded notation. So this would be our answer here. Number 5. We would read this as 1 and this would be our tenths place, our hundredth, thousandth, 10,000th. So we would pick A, 1 and 1/10,000th. For number 6, which digit is in the tenths place? So tenths, that TH means that it's on the decimal side. Tenths would be 1. Identify the digit in the 10,000s place. So here we have our hundreds, next we have our thousands, so 10,000 would be 5. And for number 8, identify the digit in the tens place. So tens place would be 2. Right, next page. What number does 6 times 100,000 plus 9 times 1,000 plus 5 times 100 plus 2 times 1 plus 3 times 1/100 represent? So our 6 needs to be in the 100,000ths place. So we can cross out A and we can cross out B. And then we have 9 in the 1,000ths place, so we can cross out D. So our answer is C. Number 10, what value of the digit 8 is in the number 3,098,430 and 651 thousandths? So our 8 is in the thousands, so 8,000. Oops, it would be not 80,000, but 8,000. Number 11, in the world today, there are about 6,083,000,000 people. This number would be read as 6 million. So we just said it was billion, so we can cancel out A and B. So this would be 6 billion and then 83 million. Number 12. To write this number in expanded notation, we have our 5 is in the billions place, so it would be 5 times 1 billion. So all of those have that as an option. Then we would have 5 in the 100 million. So we can cancel out G, and we can cancel out H, and we're left with F and J. And then next we have 4 in the 10 million place, so we can go ahead and cancel out J, because J has 4 in the 1 million place, so our answer would be F. Number 13, by how much will the number 745 96 thousandths be increased if the digit 6 is changed to 8? So this digit becomes an 8. So since that is our thousandths place, we're increasing it by 2 thousandths. So 14, which number is 11 thousandths more than 2 and 6,715 10 thousandths? So here, 11 thousandths would be written as 0.011, because this would be our tenths, this would be our hundredths, and this would be our thousandths. So this would be 11 thousandths. So to increase, we would put our decimal in line and then 0.011, and we would just add the two together. So this becomes 2.6825, which is the same as H. Okay, next, number 1. So we have 6 raised to the 6th power. So this would be the same as saying 6 times 6 times 6 times 6, 6 times. So 1, 2, 3, 4, 5, 6. I don't expect you to evaluate this without a calculator, but if you did, it would be 46,656. Number 2, which of the following is not correct? So F is correct. G, when multiplying two numbers with exponents, we add the exponents together, so G would be the one that's not correct, because here 4 plus 4 would be 8. Number 3, this is saying 10 times 10 times 10 times 10, which this would just be, we would count our zeros, so we have 1, 2, 3, 4, so 10,000. Write 100 as a power of 10. So since we have 2 zeros, this would just be 10 squared. Write 1,000 as a power of 10. Here we have 3 zeros, so this would be 10 cubed. Write 40,000 using the power of 10. So here we would need to do our 4. We can count our decimal places. So we have 1, 2, 3, 4. So 4 times 10 to the 4th power. Next, for number 7, there are approximately 950 million acres of farmland in the United States. Which of these is 950 million written in scientific notation? So I could write this out as 950 million, and then just move our decimal places to write it in scientific notation. So we have 1, 2, 3, 4, 5, 6, 7, 8. So 9.5 times 10 to the 8th power. For number 8, we have 2,000 written in scientific notation. So 1, 2, 3, we're moving our decimal place 3 times, so we have 2 times 10 to the 3rd power. Number 9, we're just moving our decimal 1 place here. So we have 3 times 10. Since we started out with a decimal, our exponent needs to be -1. Number 10, here we move our decimal 2 places. Remember, for 9 and 10, I'm only moving it until I get our number in front to be in between 1 and 10. So 3 is in between 1 and 10, so that's where I stop. Here I have 8.9, which is in between 1 and 10, so that's where I stop. And I started with a decimal, so my exponent is going to be negative, and I only moved it 2 times, so -2. 11, we just move our decimal 1 place to get this number in between 1 and 10. So this becomes 8.296 times 10. Since we started out with a decimal, our exponent's negative, and we only moved it 1 time. Here we move our decimal 1, 2, 3, 4, 5, 6 places. So we have 1 times 10 to the 6th power. For problems 13 through 18, find the value of n that makes the statement true. So here we move it 2 times, so n is going to be equal to 2. For 14, we don't even have to move it at all. This is the same thing as this, so our n would just need to be 0. So n is equal to 0. So when we make this n 0, this becomes 1. So it would just be 8.3 times 1, which is just 8.3, so that would be equal to this. If we made our exponent 1, this becomes 10, and then we're moving our decimal. We don't want to move our decimal at all, so that's why our n is 0. For 15, we move our decimal 1, 2, 3, 4, 5, 6 places, so our n is 6. 16, we move our decimal 2 times, so n is 2. 17, we have 1, 2, 3, 4, 5, so n is equal to 5. And here for 18, we need to figure out when 5 to the nth power plus 3 to the nth power is equal to 2. Here we can't combine them because they have different bases, and we're adding them. So we cannot combine them. So we need to test out some numbers and see what's going to work. So let's say we picked 1. So we have 5 to the first power, which is 5, plus 3 to the first power, which is 3. So that's going to be equal to 8. That doesn't work. That's too big. So maybe let's try something smaller than 1. Let's do -1. So if we have 5 to the negative first power, this becomes 1 over 5 plus 3 to the negative first power. This would become 1 over 3. This is going to be some decimal, which is not going to work either. So maybe let's try 0. If we have 5 to the 0 power plus 3 to the 0 power, 5 to the power of 0 is 1. 3 to the power of 0 is also 1. 1 plus 1 is 2. So perfect. That's our answer. N is equal to 1. For number 1, here we're comparing. So which comparison is not true? So we have 230 is less than 302. That's true. 7,000 is going to be greater than 4,000. So this is true. Next, we have 6,103 and 6,013. Here, this one's not true because looking at our second place here, because the 6's are the same, so we can cancel those out. We have 1 is greater than 0, so this would have to be greater. For number 2, which group of numbers is in order from least to greatest? So we have 4,000 here, so 4,000 is obviously going to be less than 5,000, so we can cancel out F and H. So we're left with G and J. So next, looking at G, we have 4,847, that's going to be our smallest. Then we have 5,486, 5,648, and 5,864. So this one is a top contender because it's in order from least to greatest, but let's just check out J to make sure. So we have 4,847, that one's our smallest. Then we have 5,648, then 5,486. So here, our 6 is bigger than 4, so 5,648 is not smaller. So that does not work, so our answer is G. For number 3, which number is the greatest? So we can do our trick where we have all of them lined up and we can cancel out our first ones because they're all 3's. Next, we look at our second row, our second column. The greatest number is not going to be 4 since we have 3 5's. Next, we can look at our third column, which we have a 7, a 4, and a 0. So our greatest number out of these 3 is going to be 7. So our correct answer is A. Number 4, what number is most likely represented by point X? So here, we have 11 and 15 on our number line. If we go from 11, this one's probably 12, this one's 13, this is 14, and that's 15. So we said this was 13, this is 14. So X is going to be somewhere in between 13 and 14. So it's not 11.25, it's not 14. It could be 13.5, but it's not going to be more than 14, so it's not going to be J. So H is our answer here. Number 5, on a number line, which number would be to the left of 7.46? To the left means that it is smaller. So A is bigger, B is bigger, C is smaller, and D is bigger, so we can cancel this one out too. Number 6, a decimal with the same value as 59 hundredths. In order to make this the same value, we can add as many zeros after it as we want, but we can't add them in between what we already have. So here, it added a 0 in between the 5 and 9. That's not the same. It added a 0 in between in front of the 5, so that's not the same. Here again, not the same. So our only one that's the same is J. Number 7, the decimal with the greatest value is, so here we can do our trick where we cross out, where we line them all up and go by column. So these are all zeros, they're all the same. Next, we look at the second column. So we have 2 that have 3's and 2 that have 0's. 3 is bigger than 0, so we can cross out our zeros. Next, we look at our third column, which this A has a 0, C has a 3. So 3 is bigger than 0, so our greatest value is going to be the answer choice C. Number 8, which of the decimals is not between 121 thousandths and 123 thousandths? So this is in between. G is going to be in between. H is smaller than this, so H is going to be our answer here, because J is in between also. Which of the numbers is farthest to the right on a number line? So farthest to the right means that it is our biggest number. So doing our trick where we line them all up and look at the columns, these all start with 2's, so we can cancel this out. Next, we have our second column. We can cancel out the one with 0's because our our options with ones are going to be greater. And then we can look at our third column. B has a 0, which is smaller than 2, so our biggest number is going to be 2,120. 10. Which statement says that 17 is between 15 and 24? So 17 has to be in the middle if we're saying that it's in between. So we can cross out F and we can cross out J, because those two, 17 is not in the middle. Here, for G, we have 15 is less than 17 and 17 is less than 24. That makes sense. But for H, we have 15 is greater than 17, which is not true. So our answer choice is G. Number 11, which group of numbers is in order from least to greatest? So looking at our answer choices, our smallest number is going to be this 0.068. So our answer choice is B. 12, how many whole numbers are between 3,999 and 4,011, not including 3,999 and 4,011. So we have in between them 4,000, 4,001, 4,002, 4,003, 4,004, 4,005, 4,006, 4,007, 4,008, 4,009, and 4,010. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 numbers in between them. Okay, and that's our last example for day 1.